everyone. How are we doing? So we're going to make a prompt start at 1:15. So first of all, thanks for all coming. Can we get my slides up? Is that okay? Is that working? Hey, there we go. No technical glitches. So quickly, before we begin, I'm both the MC and the speaker at the moment, so I've kind of got two hats on. It's just to let you know about the competition that DSF are running, where if you post on LinkedIn, tag Data Science Festival, and use the hashtag DSF Mayday with your favorite thing about DSF, along with a picture, you'll be entered into a big prize draw. Now, I have entered for the purposes of teaching almost, so this is my, oh, no, hang on, it's not showing. Excuse me just 1 second. Ooh, is it going to work? Have I just broken it? There we go. So yeah, if you do this on LinkedIn, so tag Data Science Festival, DSF Mayday, picture, and what you love about DSF, you'll be entered into a draw with a ton of goodies. So it's well worth doing. I'm not officially entering. This is just for example purposes only. But if someone does give me a hamper of goodies, I'm probably not going to say no. So welcome to my talk. 10 data science Uberhacks to turbocharge your workflow. Now, I first of all, apologies for the clickbaity title. As the gift says, don't hate the player, hate the game. We live in the age of social media. I know there's a lot of great talks here, so I thought, why not? But it could have been a lot worse. So I nearly called it Big Tech Hates These 10 Data Science Hacks, 10 Reasons Why Your Data Science Workflow Sucks, and multi-zillionaire tech ninja open sources the 10 secrets that made him his fortune. And none of that's true, especially the fortune bit. I've got a mortgage and childcare, so I'm actually very poor. And also, it's worth noting that not even the clickbaity title beats the pull of ice cream, because that ice cream queue, I don't know if you've seen it, it's going strong. So maybe there'll be people drifting in and out over the course of the presentation. So anyway, enough of all that. A little bit about me. So I've got 20 years experience working in data, 8 years doing data science, data engineering, machine learning engineering, kind of broad skill set, jack of all trades, master of none. I am a hands-on practitioner. Despite the head of title, I still write code. I love writing code. And I do love hacks. I love little things that can make my job a little bit easier. So for reference, I'm the kind of person who stands in the exact spot on the train platform to get on the train at the exact spot, to get off the train at the exact spot where the escalators are to maximize my free time and shave 6 minutes off my commute each week. I'm that kind of person, and that carries through into my coding as well. A little bit about my company. I've recently joined Station 10 as head of data science and head of AI and data engineering. Sorry, I changed the job title when I got there. And we do 3 things. We do digital analytics, which we've done for 12 years. We're very good at that. So that's things like if you've got an e-commerce website, we can tell you things about conversion rates, how your website's performing, all kinds of amazing things like that. Strategy and insight, which is kind of delving into the depths of the digital analytics thing and pulling out hidden patterns. And my area, AI and data engineering, which is pretty self-explanatory, but we do have a focus on using digital analytics data. But that said, you know, the team's really good. We can turn a hand to anything within reason. So, what this presentation is. Now, despite the clickbaity title, it's not, it's perhaps not what you might expect, I guess. I'm not going to be telling you ways in which you can kind of, cheat or anything like that. Last year, I gave a talk on Dask, which is kind of like Spark, but in pandas. And turns out a lot of people there didn't know that PySpark now has a pandas API, which I don't know. Nearly everyone I've spoken to prefers pandas to PySpark. And that actually got me thinking. Well, what else might people not know? Tech moves so quickly. It's difficult to stay abreast of all the latest kind of developments, new packages crop up, new ways of doing things and so on. And there's a lot of stuff out there that I really like and I use a lot, but I can't, it's a 2 to 3 minute thing. I can't spend a whole talk talking about it. So why not collect the best ones, in my opinion, and then talk about all of them? So that's what I've done. I've come up with 10 things that can make specific jobs or tasks or little things you might need to do around AI and data easier. That you might not have heard of or might not be using. They've got to be easy to pick up and integrate. So I appreciate that many of you work for big corporates with stacks. So the idea is that there's this neat little package or neat little thing that can come in and do this specific job for you and make your life easier. Apologies to our users, particularly Amit. I know Amit. Yeah, thank you. Thank you. Already a heckle. Oh, well, do it again. I'm going to have to break out the heckle put downs. All right. No, I know Amit, we go way back. He's a fanatical R user. So apologies to Amit and those like him, but this is mainly Python-based. Some of them will be applicable to R as well. And the biggest thing is they've got to be showcased in 2 minutes or less. So the most important person here is Shaney. Say hi, Shaney. Shaney is our timekeeper. He will be keeping me right and making sure that I don't go over time. What this presentation is not, we're not going to be deep diving into anything. I'm not going to try and bullshit you or anything like that. A lot of these things, I use them for a specific job, a specific task. I don't know a huge amount more than that. It's just a way in which I can share them with you. And yeah, I'm not going to be telling you about hacking outcomes or cheating at AI. I really believe, personally, that it's an important job, especially nowadays, that we should be doing properly. And lastly, a little rant about ChatGPT. There's nothing in here remotely ChatGPT related. It's not about large language models. Personally, I love ChatGPT. I really like it. But I really love and like a lot of things, like pizza, for example. And what I'm starting to hate, is ChatGPT's everywhere. So I look at LinkedIn, Twitter, my Facebook feed. I go out, my friends and family are talking about it. So I'm a little bit sick of ChatGPT. And I don't think I'm alone, put it that way. So yeah, we're not going to be talking about ChatGPT. Sorry, I'm just going to get my timer back up. OK, we're doing all right for time. We're doing all right for time, but Cheney's got us. Cheney's got us. So, introducing the 10 Uber hacks. Now, I'm not going to go through these individually because, as I said, I've allowed myself around about 2 minutes to talk about each of them. So when we get to them, we'll start talking about them a little bit more. But there you can see, if you already know those 10, feel free to leave. I don't want to waste time. But if you feel there might be something there for you, then by all means stay and we can chat. So the first one is GitHub awesomeness, awesome curated content. Because Google's, when you're researching something and you Google's always trying to sell you stuff. There's promoted links and that kind of thing. And what GitHub awesome lists are, and you can have GitHub awesome machine learning, Python, data engineering, etc. They're a community curated and moderated page with lots and lots of stuff on them. Basically, a set of wide-ranging resources. And I'm actually going to click on this. I'm going, is it going to work? Yay, it's going to work. But not for you. Hang on. Right, so now we're going to lose valuable seconds whilst... is it going to come back? OK, so this is awesome production machine learning. And for those that haven't seen them before, they look like this. There's a big, long list of resources and stuff with a brief description of what it does. And trust me, this is an amazing way to research an area, a new thing. The other day, my boss asked me if I could do Edge AI, and I had a look at the Edge AI list and was able to deduce within 20 seconds that no, I couldn't. So yeah, they're really useful for that kind of stuff. And I picked a good one. This is just a quick shout out to my friend Alejandro. He actually created and curated this one a good few years ago about production ML. It's now got 13,000 stars. And this is a really, really good resource. So yeah, that's GitHub awesomeness. Hang on, I just need to go back in. OK. So for each of these, we'll be doing the pros and cons. The pros, it's a great starting point for research, open source centric. They tend to be really exhaustive. People stay on top of the development, so it's a good way of learning about stuff. It's quicker than Googling. And it's an opportunity for people to find more Uber hacks. So maybe next year I can be in the audience, and one of you can come up here, having done all this, and be presenting to me, and I can be writing stuff down, which would be really cool. Just do be careful, because there are multiple lists for the same topic, and some lists aren't updated regularly. So be sure to check the last time it was updated on GitHub before you use it. OK, we're doing all right for time. Number 2, detail. Has anyone heard of detail? OK, right. I love detail. It's probably my second favorite one. So like when you've got data and you want to actually physically eyeball it, you don't, and you kind of think, well, I can download it as an XLS and put it into Excel. And then because it's 500 megabytes, it takes about 6 years to load, and then Excel crashes. Detail is the package for you. It basically generates an interactive dashboard, either in your browser or in your notebook, that you can actually eyeball and explore the data frame with. So we got another live demo. So I will have to quickly, excuse me. And there's one more live demo after this, and then we're done with the live demos. And these are just websites. Oh no, damn it. Sorry. OK, is it going to come back? And this is actually Titanic data. So this is what the dashboard looks like. It's really, the thing I like about it is you see all the data in the order. You don't just get the first few lines, the head and the tail of the data frame like with pandas. And when you scroll through, it will update automatically. So it will only load what it needs to show you. So if you want to look, if you've got like 20 million records and you want to look at the 18 millionth one, you can just kind of scroll down and it will still work and it will still load. You've also got a ton of options. I'm not going to click into these because the fork me on GitHub thing means that I can't close them. But yeah, you've got a ton of analysis options in there as well. My personal favorite is heat map. So if we click the age column and heat map, it will then give us a heat map of someone's age. And it's got loads of cool little bits and pieces like that. It's really fast, really simple to use. Okay, meanwhile, back at the ranch. So in terms of the pros and cons, sorry. No, it's not in memory. It renders the data via an API. So yeah, in terms of what you have to do to get that, it's 2 lines of code. So yeah, it's really easy. And then from there, it's a GUI, which you can interact with. So the good, it's really, really fast. I'm an impatient man, that's why I love it. And you can view the whole data frame. It's got a great, as you saw, it's got tons of features and functionality, which is really cool. And it does charting and dashboarding as well, and it's really easy to use. Downside is I haven't managed to get it to work on a cloud platform yet. And it does use some non-Python syntax for filtering, which takes some getting used to, and it crashes sometimes as well. And lastly, it does have a million dependencies to do something quite complicated. So what I'd recommend is to create its own Conda or kind of pip environment and use it from that rather than cluttering up your existing project environments with all this kind of stuff. Okay, so number 3, why data profiling? Has anyone heard of pandas profiling? Okay, a few people, yeah, okay. So why data profiling is the new pandas profiling. It's made by the same people. It was so good, they built a company around it, which is pretty cool. If Detail does the kind of the low level, pandas profiling does the high level. And it does a kind of a lot of the EDA for you, like things like duplicates, missing values, aggregations, correlations, statistics, and so on and so forth. There is, with trepidation, I'm going to click the live demo link. Hopefully I won't mess it up this time. Come on. Yes, so it gives you an HTML report, basically, where you can look at statistics, you can look at all the columns. So if you want to select, you pick a column, it will give you more data on that particular column. So if you want to see a breakdown of age, you click more details and you've got a load of options in there for age. It does things like correlations and interactions as well and missing values. All the stuff you're interested in when you're first picking up a data set. And looking at it. And it does that in a few seconds, which is really cool. In terms of the pros and cons, oh yeah, sorry, the code. The code is, again, 2 lines of code. So we've had 4 lines of code. And now your EDA is way easier. You're welcome. Good things, it's also 2 lines of code, saves time, plotting and correlating and all that kind of thing. And it's simple and explorable. Has modes for dataset comparison, so if you've got 2 data sets you want to compare, it can do that for you. And it's got a time series option as well, so if you want to do some analysis on the time series, that's pretty cool. And it makes it look like you've done more work than you actually have, which is why I like it. Bad news is it's slow if you've got larger data sets, though it can run on Spark, and it's got quite a limited scope. It's not going to do all of your EDA for you. Okay, so the next one is the fuzz. And this one didn't actually have a logo, so I had to go on the internet and find an appropriate logo that I found appealing, and that's the result. I might actually send it to the guy who runs the repo and say, look, got your logo. Yeah. We'll see how that. We'll see what it does. So yeah, it's basically easy fuzzy joins in pandas. If you've got 2 sets of data and the keys are similar but not identical, the fuzz will actually allow you to match on those. And they've got a wide range of matching options, which we'll look at when we look at the code. And yeah, it's really useful. I must have used it 40 or 50 times in the few years I've known about it. It comes for things like geography, where I'm trying to merge on the county of England or what county in England. It's really useful for kind of matching up city of Bristol with Bristol, city of, and stuff like that. In terms, so you can see you've got kind of a few options. It will actually give you a score to tell you how well it's matched. You can match just a basic match. You can ignore special characters, and you can look at just the words rather than a sentence, so ignoring the order. I mainly use choices, so if you've got a data frame with a column and you put a list of all the other values, you can actually compare the two using by creating a function and applying that to a data frame. Really, really useful. Again, maybe 3 or 4 lines of code. and solves a really big challenge. It's really simple and effective, and it's dead quick, considering what it is. And it does make dirty joins possible with a degree of control, so you can look at how well the two kind of columns match. And it's versatile. You don't have to use it in pandas. You can use it for whatever if you've just got two lists, strings of lists, or whatever. It's also downside if you've got a lot of data. It's really, really slow. And I would actually recommend there's a relatively new product out called Splink, which my friend at the MOJ has done. And that does a similar thing, but at scale, and it integrates into cloud platforms. So yeah, give that a check out as well. I will mention that later again as well. And you do need to be careful when you're fuzzy matching that you make the correct join. Okay, just check how we're doing for time. Yeah, we're good, we're good. Cheney's giving me the thumbs up, so I know I'm on track. It's one thing me saying I'm good, it's another thing Cheney saying it, so thank you. Open data. Now, who here has used any ONS open data or UK open data? Yeah, a few of you, that's good, that's good. Okay, I really love open data. UK's got tons and buckets of it. Mainly, I use the stuff from central statistical authorities like ONS, GovScot, NERSA, and so on. And it covers a multitude of areas. And bearing in mind, we just had a census in 21-22, so that data's fresh, and it's there to be used to enhance outcomes. And it can enhance outcomes really, really well. I've been using it for the past kind of few weeks in my new role, looking at building per capita comparisons between areas, which is a really good way of actually being able to compare geographic areas. And it's also got huge breadth of data and quite a deep granularity, particularly on the census data. Yeah, range of geographic breakdowns, and the ONS Geo portal is actually really, really good if you want to build maps and stuff off it too. Not so good. The ONS website isn't the best one. Sorry, ONS, big fan. But appreciate, the website may not be the top of your priority list in these kind of economically challenging times. And you do need a little bit of geographic knowledge to be able to use it, but not much. The biggest thing is that it's time-consuming to collate and maintain. Like, you've got three statistical authorities for the UK. For some things, you're going to have to collate all three of those, and actually keep them up to date. So bearing in mind, if you're using postcode to merge onto your data, which you will be, yeah, you've got to keep the postcodes updated every 3 months, and that quickly becomes a data engineering challenge. Okay, quick sales pitch. We do this at Station 10, so if you do want some open data, come and give me a shout, and we'll be more than happy to collaborate with you. Okay, yellow brick, easy AI visualization. So we've all been there. You build an algorithm. You think, oh, I want to visualize the feature importance of my boss. And then you go to Google and you find something that someone wrote in 2015 that builds a really crappy looking bar chart of feature importance. And you paste that in, it doesn't work, and then you debug it, and then you have to get into matplotlib, and before you know it, you've wasted a day trying to get this graph done. Maybe that's just me, I don't know. Yeah, so yellow brick can help you there. It's a Python package that visualizes your algorithm, so it provides kind of a visual context of stuff like residuals, ROC, curves, all that kind of stuff. It extends scikit-learn, so it works in conjunction with scikit-learn, and there's literally so much there. I think for pretty much every use case, there will be an appropriate visualization. You can see here, I think that one's residuals, like a precision recall curve, elbow for clustering, cluster map. Yeah, there's tons of stuff, and they all look really pretty, which, yeah, I like. I like pretty stuff that looks slick. Again, it's one of those things that's actually quite easy to get started with, but as we go through this list, things do get a bit more complicated if you want to kind of master them. So yeah, basically, you wrap. So if you've got your scikit-learn model, which is the model here, so we've got logistic regression, you wrap your model in the appropriate yellow brick class, and then that you can then fit and train through your visualizer and actually generate the visualization like that. So, in pros and cons, it is really beautiful. I hope you agree. There's tons. I think there's somewhere between 75 and 100 different charts that you can use for different use cases, and it's simple and works out of the box. It's really good for prototyping, and it's worth mentioning that the documentation is really good as well. And the examples gallery, you go look through the examples gallery, find something you want, and then it will take you to the code. Downside is it only works with scikit-learn, so if you're doing any kind of deep learning or non-scikit-learn stuff, yeah, you're out of luck. And also, because it's a wrapper around your scikit-learn model, if you're using other wrapper objects, which you might be around your model, yeah, that will probably cause you issues. And also, if you want to use kind of two different sets of visualizers, you might have to train it twice. And similarly, if you forget about yellow brick and think, oh no, I've got to wrap, you train the model before wrapping it, you're going to have to train twice then as well. Last thing is, whilst the charts themselves, whilst these look really nice out of the box, you have to customize them with matplotlib, which is a huge pain. So if you want to make the title bigger or get rid of the grid lines or whatever, that becomes a hellish job. Cool. So in terms of, we've been there, sorry. Cool. So SHAP. Now Eduardo's smiling. Yeah. So when I was looking at the agenda, I like SHAP. So the next two are areas that perhaps I haven't used as much as some of the other stuff here. And SHAP is all about AI explainability. And I saw Eduardo is doing a talk on SHAP at 3:15 in 3:15 next door. So I did say I'm going to send any questions your way, and he's here. He knows this, and he's here. So thank you, Eduardo. But yeah, AI explainability. And a question came up on this at the talk this morning about shapely values and that kind of thing. And yeah, explainability isn't just for stakeholders. When you consider the amounts of data that we train and use with models, and how the model respond to different parts of that data, that's where something like SHAP can come in quite handy. It uses game theory to help explain the predictions of the model, and it doing that, it calculates the contribution for each feature for each row. So the individual cells in your data set, you can break it down to that level and see what features are actually, see how the features are kind of interacting with each other and also with the target. And it reveals where features are doing well and badly. So this is kind of the plot. So red is a positive contribution. I'm going to go to this one for this side, actually, because they don't get any love. Everyone goes that side because it's easier. So here you've got the blue, which anything in blue indicates a negative contribution. These are your features. And you can see this is for a single kind of line of data. You can see how those features are influencing that model quite simply. This is the same thing, but each one of these dots is a line of the data, so it's kind of aggregating it. And this is similar, but it's an interactive map that you can put in your notebook, and when you hover over, stuff pops up, which is quite cool. And I like that kind of thing. I'm a sucker for anything interactive. But yeah, so I mean, just to kind of reiterate, it's not, this stuff comes in handy with stakeholders and so on as well. But I think we could all maybe do a little bit with a bit more understanding of how our models are working and where they're doing well and not well in a bid to kind of see what we can do to remediate that. Any questions, see Eduardo? Good things are, sorry, I glossed over the code, which probably needs to explain this. So here you basically have your SHAP explainer. You wrap your explainer. So this is another wrapper around your model. You give it your model and your training data, and then you use the explainer to create the SHAP values for your test data set. And that's what you see. This is how you create the 3 charts on the other page. It's not complicated to begin with, I think is the important. It's not complicated. It's like being a race car driver versus a race car mechanic. If you want some quick and simple plots, that's fine. It's really simple to use, but it is really, really complex to master, and there's a lot that goes on under the hood. It works with most of the major AI libraries, so it's not just scikit-learn. And it also has a really good image tool as well, so you can see where the model, so if you've got a picture of a cat and a dog, it would show you in the picture how it's kind of dividing between them. As I said, complex to master, highly mathematical, and it's very computationally expensive, and you might have issues running it on larger data sets. Cool, we're rattling through. Okay, next up is Fairlearn. Anyone heard of Fairlearn? Someone say yeah? Okay, someone has. Fantastic. So I'm just going to clear my throat. Excuse me. Okay, Fairlearn, non-discriminatory AI. Now, regulation is coming. ChatGPT is pretty cool, as long as everyone's not talking about it. But it has kind of reignited that debate around ethics in AI. And the CEO of OpenAI was in front of the US Congress a few days ago. And I think the front page on one of the newspapers had an AI headline today. And the headline, the CEO said, you need to regulate AI. So I think it's fair to say regulation is coming. And I think making sure that your AI models are not discriminating will be a big part of that. So we like to pride ourselves on not being racist. We should also pride our models on that. We should hold our models to the same standards that we hold ourselves. So Fairlearn will help you do that. And it has two components. It has metrics, which identify which groups which can be negatively impacted by a model. And it's also got some algorithms for mitigating any unfairness as well. It's really it works in a really similar way to SHAP. You've got your, you build your model as normal, and then you kind of apply the predictions to the Fairlearn metric frame class, and then this will produce metrics which you can then so how it splits with the sensitive features, which is in this case X. Sorry, I haven't explained that very well. But basically, you run this, and it will tell you when you call these, it will tell you the score for the overall group, and it will then tell you how it's treating those different groups in the sensitive features. This does mean that you have to put this data into your model. So if you want to look at things like ethnicity, nationality, gender, that kind of thing, you're going to have to put those into your model to enable Fairlearn to kind of mitigate them. Again, this is the second example. So this is the mitigator. So we have a constraint and a classifier.
You're assuming this discrete factor is 1, right?
Can we save the questions until the end? Is that all right? So you have a constraint and a classifier. And we basically give those, you have the constraint and a classifier and a mitigator, which we build off both of them. And then we use the mitigator to train the model rather than just the model using scikit-learn or whatever. And that will then mitigate it. So it is quite easy to do, but yeah, under the hood, it's incredibly complex. And I think with this kind of thing, you probably do need to understand it. So maybe this isn't one that you can pick up and use straight away. I mean, by all means, have a play with it. But yeah, there's a lot more going on there that you should be understanding. Integrates really well with major AI packages, a wide range of fairness metrics and algorithms, great documentation. And it's also, the whole reason I know about it is because I took the Azure Data Scientist exam, and it's now integrated into Azure. Which is great. I'm glad that, because Google don't have it, Google have got something a lot less, and I think Amazon have something similar, but it's good that the major cloud providers are actually picking up on this stuff, and it's also ethical and the right thing to do. Last thing, lots of good things, it is another wrapper, not great. It's highly mathematical, and like SHAP, it's really computationally expensive. And like I said, you need to find that data around ethnicity, religion, immigration, nationality, and so on, and put that into the model in order to be able to mitigate it, which is a good use for the open data that we talked about in number 5 or 6, I don't know. And last thing is, your model's probably not going to perform as well as it would without the mitigation, but it will be fair. And again, this comes back to it being ethical and the right thing to do. Okay, so Metaflow. Now, I first used this 2 years ago to build some pipelines. It was a really nice little package that enabled us to orchestrate all of our data and all of our models on a single kind of Linux server, which was really nice. And that's why we liked it. And I thought, actually, I should include it in this talk. I've since come back to it, and it's grown. It's grown exponentially in the 2 years, and it's now a data science project manager. Which I don't really understand all of it, but I know that it's really good for pipelines. So yeah, it's Netflix open source, and it's kind of an orchestration tool that you can build in project pipelines. So if you want to manage a train pipeline and a serving pipeline within your project, you can use it for that. But you can, as I said, we used it for kind of our end-to-end data workflow, and it worked really well. And it's also added some tools around environment management, so you can use different Conda environments for different things, which is quite cool. Basically, it will using it, you can create something like this, where you start, and you can actually run stuff in parallel on it, which is nice. So bearing in mind, Fit A and Fit B might be jobs running off in the cloud, or one of them might be on your laptop, one of them might be in the cloud, or whatever. But it kind of has that capability to do stuff in parallel, which is quite nice. And Python doesn't do kind of as standard. This is the code. Again, it's much for muchness. You define a step using a decorator. You tell what you want to do in the step and tell it what the next step is. So here we're splitting step A and step B. We've got step A, step B, and the evaluation and the end. And this code will build you this pipeline, which is quite nice. So good news, simple, versatile, and scalable. It gives you really easy parallelization option. It's kind of like a micro framework, so you've got like a basic option, and then you can install, like if you want to use a GUI, a GUI or whatever, you can install that extra bit. I really like stuff like that. Not so good, like you saw from this. This is a very simple job. You're going to be having quite long files once you orchestrate lots of jobs, and there's limited cloud support for non-AWS. Yeah. So we're down to the last one, which is Make. Anyone use Make? Okay, a few more makers. Do you like Make? Yeah, I like it too. It's one of my. Out of everything, I probably use this more than anything else. I use it maybe 50 times a day. And I call it a CLI maker easier, which it kind of is, but it does do other stuff as well. It's a build tool. So instead of, all the stuff we talked about with data pipelines, it does that for programs, and that's kind of at a base level why it was built. But it is also very, very good at building repeatable command line jobs. So, for example, like when you want to build a Docker container, or you want to run a command line application, and it's got like 16 different arguments that you have to remember, and then you copy and paste it into your I don't know, your Notion or Confluence and whatever, and then you can't. It's that kind of thing. It makes that a lot easier. You specify those complex commands in the make file, and then you run them with make command. So this is an extract from my make file, and I can't take credit for writing this. People taking pictures, don't worry. I'm going to share all of this on Monday on LinkedIn and Twitter. Yeah, and so because obviously there's a lot of code here and a lot of stuff. So yeah, I'm going to put together a GitHub repo with all of this stuff in. You can come and nick what you want. So this is how I create. So I'm a Conda guy, not a pip guy. Sorry, pip people. But this is how I create my Conda environment. So add Conda forge, because you have to now, otherwise you're breaking the law. Set the channel priority, install requirements Conda text, update pip, install requirements pip text, export the environment to a YAML, then install IPython kernel so I can use it in a notebook, and then finally MB strip out, so if I commit a notebook to Git, it doesn't put all the data in there. And the best thing about this, obviously, so, okay, thanks, Shane. I'm a little bit over time, but that's okay. We've still got time left, haven't we? Yeah, cool. We've got another, okay, so we might have to be quick with the questions. Yeah, I can give this to data scientists, and I know that they'll use it, and when I was engineering, I'm more of an engineer than a data scientist, I give this to data scientists, and I know that they'll use it, and I know that it will keep track of all of the stuff that they've installed in the repo for me. So they're not going to hand me back something where I get halfway through running it, and it says, oh, you don't have this package, you don't have that package. Yeah, the kernel's not, so it's really good for that kind of stuff. And so you just type make create environment, and it's done, it will run all this. So pros and cons of make. Simplifies complex CLI jobs. It comes pre-installed on most Linux VMs. It's easy via. No, ignore that. Ignore that one. That doesn't make any sense. I'm going to take that out. Sorry. It's hackable to an extent. I don't know how to write make, but I know enough to use it. And also, most interesting. I found out earlier today it was made in 1976, which makes it older than me, and it stood the test of time. And that's always the hallmark of something really good. If it's really old and people are still using it and it's still on VMs, then yeah, it's a good tool. Downside, it's verbose and complex. It's very unforgiving. So if you get an error, yeah, you might, it's not a simple action to solve it. And if you use Windows, it's a little bit tougher, sorry, to install. Okay, so we're going to rattle through the last couple of slides. So the bonus round. So this is the hardest thing was picking 10. This is all the stuff that I know and like that didn't make the list. I'm just going to pick out a couple, I think. Streamlit, there was a talk on that earlier. Apparently it's like Shiny for Python, which is really cool. I like Excalidraw for whiteboarding with my team. That's really cool as well. What else? Data privacy, always good. Splink, mentioned that earlier with MOJ. My friends kind of led that. I'm really, really proud of it. Really good piece of work. And also, why data synthetic? Synthetic data generator. I only found out about that when I looked at why data profiling. I looked at what else they did. I thought that's bound to be useful for test data and model training and so on. And the second bonus round, so I did try and open source on Reddit. I told them what I was doing. I told them all the same stuff I told you, and I said, give me your tools. And these are some of the things that came back. Domain knowledge, yeah, I'm going to talk about domain knowledge. Ridiculous. Communication skills, my data engineer, Excel and PowerPoint. I think you'd all leave if I mentioned those things. And the side scroller on my mouse, which I actually thought, well, that might be useful. That might be useful. Okay, so wrapping up, those 10 Uber hacks again. And I posted a link to the website. I don't know if you want to take a picture. Like I said, I'll be putting everything up on my LinkedIn and Twitter in a GitHub with the links to. So those are my socials. So if you do want, I'm going to tweet it, and I'm sure DSF will tweet and retweet it as well. But yeah, it'll all be going up on there, hopefully Monday. Sorry? Oh, yeah, sorry. Okay, cool. Sorry, I was too quick. Okay, so thank you very much. We have about 10 minutes for questions. Okay, Cheney, your time to shine. Yes, the lady here.
Sorry. Is it?
Sorry, we've got 5 minutes for questions because I think we have to get the next speaker set up, don't we?
Yeah. Okay. Sorry. I was wondering, you mentioned for a few of the tools that they have limitations with larger data, that they get really slow. Do you have any concept of what the large data is like?
If it's going to be a problem on your machine, kind of large data, which is dependent on the amount of RAM you've got. So for mine, I start to experience issues with data sets larger than 6 gig, but if you've got more or less RAM than me, you might find differently. Next question. Cheney's the man.
Hi, just a quick question. Thank you so much for mentioning all of this, but is the fuzz working for geospatial data, like
Sorry?
fuzzy matching of the spatial data? For example, if I have up to 8 digits of lat and lon to combine together, will it pick up, or do you have an other program?
If you save that as a string, yes, but it won't do it geographically.
Yeah, I mean
Yeah.
the geography.
Yeah, no, it won't do that. There's probably other tools that you can use for that.
Do you know maybe something? If not, don't worry.
Yeah, so I would do that. If you want to find 2 points that are close to one another,
Exactly, that's what I mean.
I would use
You have that long,
GeoPandas or Shapely, and you can either do that with a Euclidean or a great circle, which is the counts for the curvature down. So yeah, I would have a look at GeoPandas first and foremost. GeoPandas is brilliant. You'll love it. Cool. Geography questions I'm quite good at. I like those. Thank you. Okay, have we got time for maybe 1 or 2 more?
Hi, thank you very much. We just recently started using MLflow in our pipeline, and I wondered what your experience is with using MLflow versus Metaflow, which I haven't experienced.
Yeah, they're 2 different things. So MLflow will track and serve your machine learning models, and Metaflow will orchestrate pipelines, so you can use them to complement each other. Interestingly, number 9 was supposed to be MLflow originally, but I thought too many people are using it, I'll put Metaflow in instead. So, cool. Very quickly.
I have about another question related, like how does Metaflow compare to Airflow or to Kubeflow?
Kubeflow, they're both Airflow is complicated, Kubeflow is really complicated. Metaflow is really simple, is the best way. They've got slightly different jobs, so Airflow is more for data engineering, that's where it's used mostly. Kubeflow is for model pipelines, and Metaflow is more generic. It's less advanced than those 2 and less well developed, I would say. Cool. Okay, one more question.
Anything for visualizing graphs and exploring graph data?
You mean, yeah, have you heard of Gephi?
No.
It's downloadable. It's a software you download. It's free, and it does nodes. So you've got, like, if you have interconnected nodes, it's really good at visualizing that. There might be a Python package around it too now, but it was years ago. There's probably something better than that, but that's just off the top of my head.
Thank you.
No worries, you're welcome. Okay, that's all we've got time for. Thank you for your time. Like I said, if you want the contents of this talk and all the links and all the shizzle, those are my socials. And yeah, enjoy the rest of DSF. Thank you.